Hi guys, so for today's video we're going to calculate the final trim because of loading. So without further ado, let's get started. So as you can see here, we have the aft draft, our forward drop, and our weight, which is 100 tons, our midship, which is H, and the center of flotation, which is F, and our length between perpendicular, which is 100 meters. So the distance between our midship and our weight, 100 tons, is equal to, so the distance between over here to over here is equals to 42 meters. And the distance between our flotation and our weight is equals to 40 meters, the distance. So, and the distance between our midship and our center of flotation, which is HF, is equal to 2 meters forward draft. It is forward because it is looking in a forward direction. So the center of flotation is 2 meters forward of the midship. So if we going to put our if we're going to put our 100 tons in the center part, in the center part of vessel, it will create the body, what we call the body sinkage, or the equal value of the ship, or ma-equal ang iyang amount, or dili na ni siya inani, ma-equal na siya. So body sinkage, so the formula of body sinkage, which is W divided by TPC. So the TPC is the immersion per centimeters. So we can consider that our TPC is going to be 20 centimeter. So body sinkage is equals to weight. Our weight is equal to 100 tons. So 100 tons. So our TPC is 20 centimeter. So we're going to put it 20 centimeter, and then we're going to divide it. 100 divided by 20 is equals to body sinkage 5 centimeter. So, and if we're going to put it back again over here, our 100 tons, it will create a trimming moment. And a trimming moment is, and the formula of the trimming moment is W times the distance between the center of flotation and our weight, which is 100 tons. So 100 times, so W, which is our weight, which is 100, and times 40, our distance between center of flotation and our weight is 40, is equals to 4,000 tons per meters by head. It's because it's coming here, looking in the forward. So trim cost in centimeter. So because of the trimming moment, we're going to get the and TC, and the formula of it is TC is equals to trimming moment divided by MCTC. So our trimming moment, which is 4,000, and our MCTC is 200. So our trimming moment is equals to 20 centimeter. So to get our final draft, we need to solve for the change of draft in in forward direction and in upward direction of draft. So here here, so this is our TA, which means change of updraft, and TF means change of forward draft. So also this is our midship, and this is our center of rotation. So our midship, so we all know that the midship is 50 meters, because it is in between of 100, so 50 meters. And the distance of our flotation from the midship is 2 meters, 2 meters from here. So we can consider it that we will put A from here and B in here. So so to get the TC, our trimming moment, we're going to take so we're going to so it is equals to change in draft draft and plus change in forward draft. So the formula of our change in draft is equal to AF divide L times TC. So to get our AF, we'll just we'll just go we'll just measure it from A to F. That's so the midget is 50. So we're going to plus add 2 meters. So it's going to 52. And the length and the length is 100, and our TC, which is 20 centimeter from here, 20 centimeter. So 52 divided by 100 times 20 is equals to 10.4 centimeter. And our change in forward draft, which is TF is equals to TC minus TA. So TC is 20 centimeter minus the TA change in draft, which is 10.4 centimeter. So 10.4. So it is equals to 9.6 centimeters. And now we're going to get our final draft. So our final draft contains initial drops, body sinkage, and the change in drop. So our initial drops in forward direction or forward draft is 5. So we'll just going to put 30 over here, the 5 dot 3 1 2 3 2 3 0, and then also in here half draft, which is 7 dot 0 0 0. So if you don't know where I get this 5 and 7, I get this initial draft from here. So our forward draft is 5 meters and our aft draft is 7 meters. So I just put 30 here. So our body sinkage. So to get our body sinkage, we'll know over here that our body sinkage is 5 centimeters. So to get that 0.050, so we're going to convert the 5 cm into meters. So when we convert 5 centimeters to meters, it is equals to 0.050. So we're going to put the body sinkage, the two body sinkage here. So change in draft. So our change in draft in a forward draft is positive 0.096. So we get this from here. We just convert 9.6 centimeters to meters. And here, and the aft draft, the change in aft draft is negative 0.1104. So we also get that from here. We just convert it to meters. So if you don't know why I put positive and negative from here, so positive because our center of rotation is facing towards the forward direction, and the negative because our aft draft is going from the back version. So we just add all of this and we'll get the final draft of our forward draft 5.146 meters. So this is our final draft from the forward draft. So our final draft in aft draft is 6.946 meters. So this is our final draft. And lastly, so our initial trim which is 2 meters, 2 meter by stern, and our final trim is 1.8 by stern. So if you don't know where I get that 1.8, I get it from here because aft draft you can consider it is negative and this is positive. So we'll get that 1.8 meters, 1.8 by stern. And so to get our final So to get our final trim cost by centimeter, so we'll just mine so we'll just subtract this to 2 minus 1.8. So we'll get 0.2 m by head. So 0.2 by head. Yes, we got check in over here in our center of rotation. And if we convert it into meters, centimeters, we'll get 20 centimeters. And also we got check in here in the TC, trim cost in centimeter. So that's all. I hope that you learned. Thank you.